Okay. Yeah, just for information, tomorrow onwards, it's EMCO for a lot of plays. Oh, what is Jensen doing? I can see his mouth moving, but I don't understand what he's doing. Okay, so tomorrow is EMCO for lots of places. Anyone's place is affected by EMCO tomorrow? Yes, no, or no idea what's happening? Don't know. That is daddy, mommy's business, none of my business, right? I'm still not going to school, that's all I know. All right. So it will be tighter because the COVID cases are increasing recently. So that is why there is a EMCO and try to go out. Try not to go out if possible. All right. So today, let's go through our science for today. Let me share a screen with you. Today we're going to share about excuse me, different items have different melting point. Like for example, water. We know that water, ice, all this, the melting point is at 0. Okay, when it's 0, it will be freeze into ice, or more than 0, it will melt into water. Okay, so we have learned the melting point about ice. How about other things? Let's say chocolate. If we take out, does it melt? No. But we put up a heat. Yes, it melts. So chocolate, wax, candle. That's why you see candle when you put on the fire. At the beginning, it doesn't melt. Then later, it starts to melt with a wax at the side. Okay, so you see all these have different melting point. So today we're going to learn a little bit about different melting point for different items. Alright, so let me share with you a video on different melting point for different solids. So this is the experiment. Show how it's done.
Cambridge Science Investigators. Today's investigation. Do some solids melt more quickly than others?
Here are some ice cubes.
Here is some chocolate and butter.
These are all solids. Our investigators are going to heat each solid and see how long it takes to melt and change into a liquid.
I think the butter will melt first.
I'm not sure.
Which solid do you predict will melt first?
Okay, there are a few items here. Okay. So I need you to think about it. They are butter, chocolate, ice. Okay, which one do you think will melt first? Okay, please type in the chat which one you think will melt first. What do you think? Please type in the chat. Okay, some say ice, some say butter. 2 ice, 1 butter. Let's see the video. Ding, 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 ding. The moment of truth.
Which will melt second? And third? Let's investigate and find out whether your prediction was correct. Before they start, our investigators need to make a plan.
We have to plan a fair test.
Yes, we must use the same things to heat up the solids.
They are going to heat each solid and measure the time it takes to melt. What else must they do to make it a fair test?
Okay, fair test means that you cannot like one stronger fire, one less heat and stuff like that. So what are the things you need to use in order to make it a fair test? How to make it a fair test? Think about it. Okay, like for example, use the same pen. If not, like some pen is thinner, some pen is thicker, it's like probably it's not melting faster or slower because it is just a pen different. Okay, use the same pen. What other things you need to have a fair test? Same heat, very good. Okay, not one bigger fire and one smaller fire. Same heat, good. Anything else? Most likely you need the same environment too, because you don't say like, oh, I melt this at a winter country, then I melt that at a summer country. So because the temperature around us is also different, so you need to have the same environment as well. Okay, anything more? Nothing more? Then we'll watch the video.
Here are the ice cubes, butter and chocolate. They're all the same size for a fair test.
And we use the same pan to heat each one.
Same
Did you
pan.
think of those two things to make sure the test was fair? Our investigators also need to plan how they will measure the time and make a table to record the results.
So they need
Our
the same
investigators
clock.
are
Cannot
going
have
to
one
test
fast,
melting
one
the
slow.
ice cube. One of them has put the ice cube in the pan. The other is timing how long it takes to melt. Our investigators started timing as soon as they put the ice cubes in the pan.
The ice cubes have started to melt already. Look, the ice cubes have completely melted.
It's 54 seconds. I'll record the time.
So that's how you record the investigation.
Now it's time to melt the chocolate. The chocolates take
Okay, now again, think about it. Okay, now we know. Okay, let's assume the ice is 54 seconds. Predict how long will it be for chocolate? Just simply predict. What do you think? "96 seconds? Chocolate 27 seconds? But Harold, just now you said ice melt first. So 27 seconds is like it melt faster than the ice or slower than the ice? Oh, it melts faster than the ice. Okay. All right, chocolate 100 and something. Okay, now hold it up for thought. Okay, what do you think about butter? Butter. What is the time taken for butter to melt? Think about it. What's the time taken for the butter to melt? Okay, Joanna thinking butter is faster, so butter is 28 seconds. Okay, Harold also think butter is faster. Okay. Wow, Jensen thinking butter is the slowest. Let's see the science experiment.
taking a lot longer to melt.
Oh, a lot longer.
Teacher, can we ready?
What happened to my computer?
It's already longer than the ice cube.
Uh-oh, my whole computer started. Can you guys still see what I'm seeing?
Chocolate's completely melted. How long did it take?
It's 1 minute 55. I'll record it now.
Okay, so we found out that chocolate is 1 minute 55 seconds. That's really long.
Now our investigators are going to melt the cube of butter. The butter is melting.
The butter's completely melted. I must take it off before it burns.
It took 1 minute 9 seconds. I'll record that now.
Our
Butter
investigators are recording
is
how long it
1
took for the
minute
butter to
9
melt.
seconds. So the fastest is the ice.
Thanks for watching.
Okay. So you see, the fastest, who is the fastest that melts? It's the ice because only 41 seconds. 41? 54 seconds. 54 seconds. Butter was almost correct. Okay, you are almost correct. Okay, but butter is 1 minute 09 seconds, a little bit slower. The slowest of them all is chocolate, which takes 1 minute and 55 seconds. Understand? Okay, so it shows that all these different material have different melting points. Understand? Okay, so let's just do a quick recap. Did the time it took different solid to melt match your prediction? Some yes, some no, some are celebrating this now. How did our investigator make sure they did a fair test? They used a clock, the stopwatch. Describe the changes of butter in this in chocolate in this investigation. From chocolate bar, it become liquid. And last one is that how else they can improve? I don't know, it seems fair. Okay, that's pretty much what we learned today. Okay, so can everyone open your book? Your book, page 30 today. Book, page 30. Your book, page 30. Before that, okay, what I need you to do is that can you record the findings for the experiment just now. So what I need you to do is this one. Okay, please write the chart. Okay, draw a box like this. Why I cannot draw? Oh, found it. Okay. Okay. Right, chocolate. First experiment did is ice. What happened? Okay. Basically, what I'm saying is that what's wrong with my thing? Okay. Copy exactly the same thing, but change the salt, sugar, everything. Write on a piece of paper. Write into ice, chocolate, and butter. And write instead of melting point, you change time taken to melt. Okay. What I need you to do is record the findings. Record the findings from the experiment. I'll need you to submit this as your homework. Okay, record the findings from the experiment shown in the video. Okay, so I need one column here. It's called substance. The substance, I will need to see butter, chocolate, and ice. Another column is time taken to melt, and record the finding accordingly. Okay, record it in table. Okay, based on this table format. Okay, once done, can you show me on the screen whether you do it correctly?
Teacher, is it right? Chocolate, butter, and ice.
Yes. What's wrong with my?
Teacher, is it your annotate is white?
Oh, it's black. It's anything black. Even draw circles, everything is cannot. Stand also cannot. I can do it. I annotate it. Okay. How can I exit and come back? That's just not my phone. I'm not sure something to do with that. Okay, you try to draw first. Let me see how I can. Let me figure some way how I can draw it on for you. Okay, let me share the other screen. Okay, so what I need you to do is you draw a table. 1 item, 2 item, 3 item. Good. Okay. Draw the header here. One is substance and the other one is time taken to melt. Okay. Then the first substance of the experiment we did is ice. Then after that is chocolate. Then after that is butter. Okay. So these are the findings that you need to record down right on a piece of paper. Ice just now is 54 seconds. Chocolate is 1 minute 55 seconds. Then the butter is 1 minute 9 seconds. Okay. This is how you record the findings. Got it? Okay. Please do this. Once done, you just drop me in chat. It's done.
Can I show you if I've done?
Yeah, that will be great.
Okay.
Done.
So can I draw like this?
Yes, great. That's nice. Okay, so Dana. All right, so let's go back to our book. Okay, so let's see page 30. Page 30. Page 30. In the exercise, you will use information in the table to answer questions about melting in different substances. Salt, sugar, ice, candle wax, and chocolate. So salt has the highest melting point, which is about 800, 180, 0, and so on and so forth. Okay, describe the phase change that takes place when a substance melts. When a substance melts, is from what to what? Phase, basically the solid, liquid, and gas. So it's from what to what? Melts. Anyone would like to try? Okay, did it start from solid, liquid, or gas before it melts? What did it start with? When it's ice, when it's candle, when it's chocolate, it start with being a what do you think, Jensen? Very good. It start with solid. Okay. Then after that, it turn into solid, liquid, or gas. Now the melt is like, it turned into solid, liquid, or gas. Very good. So it started with solid and turned into liquid. Okay. Solid turn into liquid. What happened?
It turned into gas. Water vapor.
First question on it. Describe the phase change take place when a substance melts. Okay, I don't know why as soon as I click somewhere else, this whole thing will disappear. Okay, try to copy this. Solid turn into liquid. It doesn't turn into gas, okay? It's just melting. All right. Which substance in the table melts at the highest temperature? Highest temperature, which one? Harold. Which has the highest melting temperature?
I can see question 1 answer.
Yeah, it's in the chat. Solid turns into liquid. I don't know what's wrong with my Zoom. Just now it hangs. That's why suddenly you can't see me and the video hang. Then after I come back, it's just like this. Okay, number two. Which substance in the table melts at the highest temperature? Which is the highest temperature, Harold? How about Jensen? You don't know. Okay, no problem. Jensen answer the highest, Harold answer the lowest, okay? Jensen, which is the highest temperature? Jensen, which is the highest temperature? The highest temperature is, I can't really highlight, is salt. Okay, because it's 800 is the highest temperature. So question number 2, right, salt, right, salt. So lowest temperature, you see the smallest number there. So lowest is ice. Good.
Teacher, and
Yes.
I can't draw on your board.
You can't draw on the board. Oh. Doesn't matter that. Hopefully with that we start. Then you'll be fine for next class. Okay, any questions so far? Yeah. Number 4, which substance need the most heat to melt in? Need the most heat, so need the most heat is highest melting point, need more heat. So the answer number 4 is salt. Number 4 is salt. Number 5, room temperature is 22. Which substance will be liquid at room temperature? Which means that which one you put outside the place, it will be liquid. Which one you think, Jensen? Okay, which means that
Ice.
very good. Which one is lower than 22? Which is ice, the only one lower than 22. So ice would melt at the room temperature. Good job, Harold. Okay, so that's pretty much for page 30 for the melting for different solids. Okay, so next week, I'm going to show you more on how to melt all the different type of metals. Okay, next week we go focus on the different melting point of metals. Yeah. Okay, so that's all for today's class.
Gold can melt into liquid, and aluminium also can melt.
Yes, all of it can melt, but it's just different melting point.
But teacher, what is copper?
Copper, a little bit like brown color. Okay, like for example, first, second, third winner. The first winner is normally the what color? Gold, right? First one is always a gold medal. Second one, normally what kind of medal you get? Silver, right? Third one, normally you get a copper. Copper is the brown one. Okay, so you see, this is a copper medal. Normally when you're the third place, you get a copper medal. It's copper. Because gold is the most expensive, silver second most expensive, third expensive is copper. Okay? Alright, so that's all for today's class. Alright, sorry I'll end the class a little bit early today because I think, yep.
I live and I don't know what you tell.
Oh, which part you missed out?
What is copper?
Oh, I didn't touch that. Oh, you just left it now? Copper. Okay, I just closed it. Copper is the medal you get the third one. Okay, first you get gold, second you get silver, third you get copper. So this is copper. It's brown color.
Teacher, number 6 I need to copy.
Number 6. There's no number 6 or 1 to 5 in here.
Bye, teacher.
Okay, that's all for today. Bye. So I need some time to restart my computer for the next class too. Okay, any question, just let me know, alright? Okay, bye. See you then.